Okay, is the first slide displayed there?
No, it's not showing yet.
Okay.
Don't see you.
Let me,
Yeah. Here it's coming. Yeah.
got that.
Perfect. Looks great.
Perfect. Perfect. Thank you. It's a pleasure and an honor to be associated and be able to give this seminar today. I was quite lucky to have known Pete Pasqua and had some enjoyment and sometimes with his laughter and humor. So I'm proud to be here. I'm going to talk to you about the principles of fire protection in the nuclear engineering field. And it turns out that the field of fire protection engineering and nuclear engineering is so tightly interwound that we thought, and Professor Hines agreed with us, as well as the faculty from nuclear engineering, to start cross-listing some of our fire protection engineering classes. The beauty about it, and you'll see, is the fact that tight integration of the two fields is very important. And I've got a short video in the presentation to talk about one of our cooperative agreements that we had with Y12, Oak Ridge National Lab, and Pantex, some of their experiences. So like everything else, we have three learning objectives. So basically want to introduce you to our graduate certificate program, as well as now as a concentration in fire protection engineering here at the University of Tennessee. We've used the model that Case Western Reserve University also has. They have a certificate program, but they allow three separate departments to administer and award these certificates. So these are some things that we've been looking out for in the future with some of the other departments in the Tickle College of Engineering. There are some win-wins as far as the cross-departmental cooperative agreements that we may have: training, education, research, and as well as employment opportunities. I have several students who have come through nuclear engineering. One he had received a master's degree and he's already in our concentration that we have on engineering. Fire protection engineering, basically, fire is a plasma. So we actually replaced the plasma research group with the fire protection curriculum. I also want to give you some real world examples of some ongoing projects that we have in the area there. Professor Hines pretty well laid out what my background was, but I come from a unique situation. Not only am I a graduate electrical engineer, but also a fire protection engineer. And I went through the doctoral program way back when it was in its heyday of engineering, science, and mechanics, which covered a vast number of subjects that later on found useful in some of my work. Some of the years of experience I had 10 years at the Federal Bureau of Investigation, where of all things, after seeing what happened in Texas last week or the week before, we went out with the Department of Energy and did risk and hazard assessments of power grids. We did WAPA, which is the Western Area Power Administration, but we did not do Texas. And had we done it, we would have picked up some of the problems that they were associated with their denial of service. So we laid out basically the framework of how you assess a power grid. And we took all of the factors involved in it, from hydroelectric, nuclear, coal-fired, as well as gas-fired plants, and also the emergence of photoelectric and wind power. So I came from there, from that aspect, to be able to leverage that. I ended up transferring to Tennessee Valley Authority. I was the assistant chief of police in charge of basically all of the technical investigations that were going on, especially large loss fires one of the areas that one of the fire investigations that I led was the unfortunate fire at the Watts Bar hydroelectric plant, where some decaying cable came in contact with some of the inner metal structures and caused $100 million loss. And so we learned about issues of cables. And since then, we've actually got one graduate last year that actually studied the impact of fire protection spread issues on aged cable that was in nuclear power plants, as well as in radiated cable, and came up with some metrics that we found to be very significant. I've got a large range of funding history, and we were very lucky that the Underwriters Laboratory has basically, through a generous gift, underwrote the fire protection engineering certificate program, and it's much more broad than we've ever seen. They initially gave us $250,000, and then last year said, well, we think you need another $250,000 to maintain this. One of the things that we're looking at is the cross-fertilization of the faculty to help teach some of these courses and mentor additional folks. These are the offerings. We basically started out with 4 courses for a graduate certificate. EEC 563 is now cross-referenced. There's a nuclear engineering equivalent course number for that. But we also have enclosure fire dynamics. We have a forensics engineering class, as well as a class in high-performance computer modeling and visualization. One of the areas that is most effective is the use of computer fire modeling in determining what may or may not happen in a power plant. And the Nuclear Regulatory Commission has funded a great deal of this work. We were also developed a course several years ago through your department in computer fire modeling for nuclear engineers. And so that course could always be revived. And I've included that in the 575. We also have some other upper level courses, principles of electric flash hazards and explosions. We got a call from one of the large DOE facilities to say that the arc flash hazards has become a significant issue, and that all of their engineers and specialists need to be retrained for that. We've added a fundamentals of radio and satellite communications because now alarm systems are now wireless. So we felt that the fire protection engineers or folks who wanted to cross-reference that needed to know more about the wireless aspects of it. Software-defined radio was the advanced course, and then we added a wildland and fire threat assessment course specifically aimed at electrical power generation and distribution. We were able to gain access to Gatlinburg after the fire several years ago, and made some determinations about what had happened with regards to the electrical power grid there. One of the most significant facts was that the Gatlinburg Fire Department failed to be able to turn the water on because they used a wireless phone network to actually turn on and turn off the water supplies. Of course, with everybody in a panic mode there, the majority of the folks were on their cell phones, and that created a denial of service. So that's one of the underlying aspects of what happens. So as you can see, there's a broad range of topics and areas that the fire protection engineering group takes a look at. So one of the number one question comes up in the class: how much am I going to get when I graduate? So I checked today, and as of February 17th, just a few days ago, the average salary for a graduate fire protection engineer, and that's at the bachelor's level, is almost $100,000 a year. So there's a great number of jobs out there. In fact, Oak Ridge National Lab has a billet of about 50 jobs they'd like to fill, and they vary at 20 to 35 actual fire protection engineers on staff out there. But you can get jobs, government agencies. The Nuclear Regulatory Commission is one of the largest hirers. Municipalities, consulting and engineering firms are big right now. I get a call a week from headhunters looking specifically for engineers, especially in the forensic research and testing capabilities. Insurance companies, equipment manufacturers, and academia. We're one of the few programs in the country, in fact, in the world, that offers an actual certificate program. And you'll see here in a few minutes, it's totally online. All of these classes, as we discussed, and in the previous slide, is that started in spring 2021. All of the certificate courses are delivered through UT's distance education program. That allows flexibility. We've gotten calls now worldwide. The India Institute of Technology is asked to cross-reference our courses as well as to leverage that. Turns out that if you're in the distance education program, you're paying less than the typical tuition you would pay on campus. And the difference between in-state and out-of-state is about $250. So these are some things that we're going to see. We have prepared almost 2 years ahead of time to go through the distance education program. And we just happened to be in the right place at the right time, because we just turned the switch on and started the delivery through Vols Online. Let me give you a little bit of background about Oak Ridge National Lab, Y12, and Pantex. Wanted to get some of our expertise, so they asked us to compress our courses down from 1 semester to 3 weeks. So it's 40 hours of classroom as well as in laboratory situations. And we were able to offer all 4 courses in 1 summer, which was it pretty well wore us out. But I wanted to share with you some of the feedback that they had. And this is a video that Y12 put together regarding the summer classes that we had. I don't know if you can hear the audio from this. Is the audio coming through?
No.
No. Best laid plans. Anyhow, this is a course in which we put this on, and they were actually able to document and give us feedback as far as what was happening. Let me see if I can change. Best laid plans. Anyhow, in the video, it talks about the facilities, the fact that we use the Knoxville Fire Department at no charge. We also allowed in their forensic investigators into that program. So we can post this later for you if you'd like to see it. But we went through all of the aspects and got some significant feedback from Y12, ORNL, and Pantex. So here are the win-win opportunities that I see. One is in fire protection analysis. It's very hard to get fire testing done, especially with the issues of EPA and things like that. However, if you've got a good working relationship like we do with the Knoxville Fire Department, we aggressively work with them, and they have a full burn facility there. We just provide the instrumentation. So we can do live fire testing, look at building components, look at issues such as suppression systems, detection, as well as alarm systems. So we have access to that at no cost. So we have used the facility in the past and continue to do it. One reason was that years ago I ran their arson squad when I was also early teaching. I graduated from UT and was teaching part-time as well as full-time running the fire investigations unit. And so with that cooperation, we gained an opportunity to be able to use their facility at no charge. Typically, a fire test, if you went to a commercial lab, they would be charging you $10,000 to $20,000 a day to do fire testing and use their facilities. Not only do they allow us, but they also provide the suppression activities to basically control the tests should one get out of hand, which they haven't done so far. In the fire dynamics fundamentals, which is basically combustion science, that's the fire dynamics, like I mentioned previously, had to deal with plasma, and fire basically is a plasma. So we've been able to apply all of those principles and techniques. We've been recently working at modeling aerosols, such as if you had a contaminant, a radiation source, anything like that that could become in an aerosol form. We even have been gotten questions about COVID, and we definitely can use that opportunity for that. So we have some computer fire models that rely on basically CFD code, computational fluid dynamics, that allow us to do these. The code is free, and it's developed by the National Institute of Standards and Technologies. So those become very, very important, and it's a valuable tool. We also worked with the Department of Energy to come up with their latest model that's now certified for use in all DOE facilities. And it's a zone model where you can get the results in minutes rather than hours or days if you used a CFD code. We're also very actively involved in looking at smoke control and management in these design areas. So it turns out that in the majority of the fires that we see, especially the ones involving serious injury or fatalities, it's the smoke that is actually the most toxic component. So we look at that and analyze it, and as well as the computer models that we have can realistically predict the smoke control and movement from that, as they also can determine when activations occur based on smoke alarms, as well as heat detectors and the activation of sprinkler systems. So this has become a unique aspect that we've had. We're also talking about win-win opportunities. We work closely with Evans Line, who's a professor in mechanical aerospace and biomedical engineering. And he is not only a combustion science PhD, but he's also a practicing physician, so he has an MD degree. And he helps us out with this issue of looking at the toxicity or toxicology. And it basically comes down to a term they call tenability, whether or not you'll be able to survive a situation like that. And then egress and occupant movement. One of the areas in computer modeling that we have the opportunity to use is an egress model that accurately predicts movement of individuals through a building and through the evacuation, as well as what impact it might have with the modeling when it comes across when they're going down a corridor or trying to escape through one loop or another. So we've been actively involved in that arena, and so these are some of the things that we can bring to the table. We also work with there's a top software engineering firm that actually has a graphical interface to all of the NIST free code. And so we work with them, and they have provided with authorization from UT's Office of General Counsel, they provide us and provide all the students free their graphical interface, which basically reduces the development time of fire models from weeks to hours. And so we've been very fortunate with some of these opportunities that we've had. So there are some critical threats to power facilities by wildland fires. This is just recently picked up, of course, with the Gatlinburg fires. We had basically a denial of service with the power facilities. If you've been watching what is going on in California and out west, we will continue to have these types of areas. So one of the projects we did, and this is a project that Jimmy Landmesser, who is one of he got his Master of Science in Nuclear Engineering, has come over. He works at ORNL, and he is looking at the issues, and these are modeling. Basically, this is a wildland grass fire as it passes along and comes adjacent to a wall. And the issue is, what is the size and height of the wall or the materials that will prevent the fire from exposing combustible materials on the other side of the wall? So these are basically examples. In fact, I ran this for him the other day. We have a high performance computing, a small grid that we put together, and we can do this entire run, which is in the past takes about a day to do. We were able to reduce the runtime to less than 4 minutes. So those are some of the capabilities and things that we've done with computer fire modeling. One course, ECE 575, which is a high performance computing, we actually teach the computer scientists and engineers how to develop and use their own grid, basically, and actually just take a series of old PCs, gang them together, and actually produce their own high performance computer at home. So this has become very popular lately, especially with the limited resources sometimes that you have. So this gives you, and for example, this is giving you in real time, in seconds, what has happened, so you can actually move along the development of the fire. In this case here, there's a vector analysis.
Hey, David,
yes.
Sorry to interrupt you. There are some things in chat. All that we're seeing is the picture of your video of just you. Nothing's changing. We're not seeing any other slides. Are you going to some other slides, or are you just?
That's on the slide. Let me go to the next one. This is
No, we're stuck. We're still on. When you tried to run that video,
okay.
Maybe a minute, and then it kind of froze, and we're still back there.
Okay. So going now?
No.
Okay. Let me step to the next one.
Yeah, maybe you might just have to shut down out of that PowerPoint and restart PowerPoint. I don't know.
Yeah. Is the slide rotating in this one, or is it still stuck in
No,
that?
we all that we see is there's a picture of you. It says Dr. David Icove, coordinator, UT Graduate Certificate Program, and it's been stuck on that since you got there.
Wow.
Sorry, I should have said it earlier, maybe.
Yeah. Let me do a stop share.
Yeah.
Restart it. How's that? Is the
Yeah, now we can see that.
okay?
Great. Sorry.
Yeah, sorry. That technologies,
Yeah, every once in a while it surprises you.
So is this, this is the example of what Landmesser is doing as far as looking at the threat. And can you all see basically the vectors as they move?
Yeah, it's pretty cool.
Yeah, it is pretty cool. This is public domain software that came from NIST. The only difference is the graphic interface we've been able to obtain. So the issue here is whether or not that you can establish a barrier wall that, and especially with some of the remote DOE and NRC and other facilities, to prevent a passive a barrier to prevent a wildland fire from encroaching onto the lands of where the facilities are. So this has been a significant problem just recently, and like I said, it was from the Gatlinburg series that helped it. Let me go to the next slide. Can you see this one? It's rotating.
Yes. Yep. Everything's good.
This is, if you look down here, that's where the aquarium is. This is the hillside from Gatlinburg going up to the other side. So this came to us from NIST. They gave us the code and they said, can you please see if you can accelerate and reduce the times that it takes to produce this model. So those are some things Dr. Michaela Toffer and her research group and I are working on that, as well as Jimmy Lamesser. So you can actually realistically see as the fire passes over the top and goes down to the other side of the mountain. One thing that we did was we actually tracked where the fire actually really occurred and have been looking at from that aspect. So egress and occupant movement is an area that is of great significance, especially in the evacuation of facilities, as well as evacuation if you've lived in or you've visited areas of close to the nuclear power plants the TVA has, you'll see evacuation routes. But one of the concerns we had were in building evacuation itself. So can you see this one with the people?
Yep.
Yep. This is an actual model. This is Thunderhead Engineering is like I said, has given us this full model to allow us to do this. You can see the patterns there on the floor are basically the closeness that the individuals can have to one another. And so this was the basically going down the stairs at Min Cow. This is one of the students provided this. You can figure in gait, there's somebody running down the stairs, and gait experience, as well as his age of how the mobility that somebody might have. So we thought this was a significant project to use with the fire protection engineering work, especially in the area of life safety. So here's sort of conclusions. Like I said, I wanted to look at some win-win opportunities in merging and cross-referencing our courses between our departments, as well as through all of the Tickle College of Engineering. We see that there's some win-win cooperative training, education, research, and employment opportunities. I serve on, have served in the past and will continue to serve on as the external member of any of your department's committees, as well as participate in some research and any other type of education that might exist. So these are some things that are important. Some of the win-win opportunities we've had is that we've built these courses with no copyrighted materials. So we've been able to, some other universities have asked for them, but what we'd like to do is make them available to your department also. And like I said, there was a couple of real world examples that I had on some ongoing projects. And some of the other areas that we were looking at was nuclear security and things like that, the exposure that I've had in the past in working with that, especially with Dr. Hall. So, questions? This is time for stump the chump, as they'd say.
Thank you, Dr. Icove. Sorry we had some technical difficulties in there. Um, have you been involved at all with well, Promise is going to have a question here for a second, but I have the mic, so I'm going to go first. Were you involved have you looked at the design of the new engineering complex, the Xena engineering complex?
I have, in fact, I was on early on, talked to Dr. Stanfield about that. And one of the concerns that came about was ventilation for three. So I'm on the UL advisory board and on the board of directors, and each year did a briefing about the safety issues that are involved. So UL is very concerned about that. And it turned out that the design of the hoods that need to go out, as well as the ventilation, I addressed that with Dr. Stanfield and thought that that's something of concern. So yeah, I've taken a look at that design. I was pretty well.
Yeah, I think it's pretty interesting because you have like a 6-story building with the staircase that wraps up. So you have, all 6 floors are tied together with that staircase. And, I guess at the top of that staircase, they have some huge fans, which will somehow try to suck the smoke out. So each of the 4 wings has its own fire escape at the end, but I guess if people wanted to try to go through the stairs in the middle, then there are these huge fans that kind of try to suck the smoke out at the same time. Is that right?
Yeah, that's a classic problem, and you see that design also in if you go to an Embassy Suites or a Renaissance, and there are massive exhaust fans that are up there. They also use, and I didn't check to see if in this design, but they'll also use some type of detection, and laser beams are sometimes used, but that's in the enclosure fire dynamics portion. We concentrate on some of that work of basically predicting what the plume is going to do as far as smoke generation. Of course, you don't want to be if it's a failed system, you don't want to be at the upper levels. We even had the experience for testing Brushy Mountain Prison before they renovated it back in the late 70s, and actually set some fires in their cells and used laser beams to look at smoke obscuration, which was way advanced at that time. And some of the other agencies came in and take a look at what we're doing. But yeah, that's a classic issue. Of course, in Min-Cow, we still have the same atrium issue that they have, as well as in the new the new student center has some of that area. So they're very concerned about door closures and things like that during that time. The Panhellenic building is now, I'm not quite sure why they did it, but Panhellenic, they've basically stopped the use of the top floors in that building. So, but the atrium construction is a unique issue. Also, in nuclear power plants, you can't get away from that as far as some of the issues. So if you have disbursement, like I said, right now we're looking on a project of what do you do with leaking propane as well as other solvents? How do you predict the movement of those, as well as the hazardous conditions that might occur? So yeah, it's a unique background, and like I said, the theme of that building was supposed to be safety, and that's and those are some of the conditions that they had with it. But it's a very good design. I how it came out.
Yeah, the other thing that was interesting in the design of that building is, the state fire marshal said, the whole building is going to be sprinkled. And we were building what's called a fast neutron source down in one of the shielded areas. Heavily, we have walls that are 3 to 5 feet thick concrete down there. And if you have a fast reactor or a fast core, it's not a reactor, but the planning is, that means that you don't have any moderator in there. And water is a moderator. So I remember some of our early discussions. I'm like, we cannot have any sprinklers in that room. And they're like, no, we're going to put a sprinkler in that room. And I said, well, if you put a sprinkler in that room, I'm putting an umbrella, under your sprinkler, because it can't get on this, it can't get on this core, because then it can go critical, super critical. So we went back and forth, and then we finally, I guess we talked to some people, and we ended up also talking to Nuclear Regulatory Commission, and our thought was, if there's any kind, that you have administrative controls. The administrative controls are that you don't put flammables in that room.
Mm-hmm.
Don't store paint in there. You don't put wood in there. You don't put flammables in the room. So those are the administrative controls. And then the operational is that if you get it, you just shut the huge door and you let it burn itself out. And they did the study showing, it burns itself out very quickly.
Mm-hmm.
And he says, that's what you do in a room like that. You shut the door, you let it burn itself out. And the state fire marshal, then approved it. But I thought that was just really interesting.
Yeah. And like I said, those are classic problems. So basically of how to get around that. And that's why the modeling becomes so important. Mm-hmm. I'm sure they ran a model
yes,
to do that.
Yeah. Okay, Promise, you've had your hand up for a while. It's probably getting tired holding up like that. Why don't you go ahead and ask your question?
Thank you for the talk, Dr. Icove. My question is, can you just speak a bit more on, I think the class was ECE 575, the computer modeling? What type of assignments do students do?
In that class, it gives you basically a complete overview of high performance computing, but we apply specifically the fire models to that because they lend themselves so greatly to that. We teach how to use basically multiple core machines and to take advantage of that. In order to do some of these large models, you have to break down the dimensions into smaller mesh sizes, and each mesh becomes a cube of itself. What you can do is if you have, say if you have a quad processor on your laptop, you can assign each one of those areas, those cubes, the computational requirements, and then when they're done, they merge all of the data back together again. So it's a unique approach in parallel processing. So we teach how to use that. We give the software out that allows you to quickly put it together. Doing high performance clusters can be very time consuming, as well as it limits yourself. I've tried to do it myself, but some of the software that we're given now automatically puts that together. So one of the exercises that's coming up in that class is to take, as I mentioned, several older workstations and that you might have kicking around at home, and actually interface them to allow you to build a low-cost cluster. So that's those are some of the areas we have. Just recently, I've been purchasing. Hewlett Packard has a low-cost workstation now that uses the Ryzen chip, and you have 8 cores in there, which gives you 32 threads, so you can have a 32 mesh problem worked out. And I think the workstations are now $500. I mean, it's just amazing what's happening in the field and knowing what to do. So, and the reason we have this course is because after graduation, 9 times out of 10, if you're doing anything in the fire protection field, is Dr. Hines mentioned, is someone's going to ask for a model before they go any further. So we want to give the students who take that class the ability to hit the ground running, especially when their boss turns to him or her and says, we need a model, and all we have is a couple of old workstations here, and do what you can. And so this is an opportunity. This course doesn't exist anywhere in the country. Nobody teaches how to do this. So we stress that. We also take a look at some of the other issues of how do you speed up the area. NIST came back to us and wanted to know why we got their wildland fire model running about 20 to 30% faster than the one that they had. And we basically had said, well, we know the chip issues, and we just recompiled your code to specifically address those chips. So those are some of the tools and techniques that we have. But that 575 has become a very popular course that we have. There's also another course that's not on the list. It's ECE 463. It is a data center design, and you actually get to go out and redesign or do the future design of the high performance computing at Oak Ridge National Lab. So that's a course that if you're interested in larger, in getting training in how to operate and build large high performance computers, that's a companion course that goes with that. We taught it last semester. We had to cap the course at 50 students because we thought we were still going to be pre-COVID, but we took advantage of distance education and moved it all over to that. So those are some of the things. Yeah. Does that answer your question about that course, 575?
Yes, it does. Thank you.
Yeah, I can circulate for you if you send me an email, I can send you all of the syllabi for those courses if you need. Basically, it's down to a day by day what the assignments are and things like that.
Awesome. Yes, I will email you. Thank you.
Yeah, thank you.
So Dr. Icove, Dr. Upadhyaya has a question for you in the chat. It says,
Okay.
presentation, in case the water mains freeze up, is it possible to use chemical fire retardant safely to put out residential building fires in a city? He said this was the case in San Antonio recently.
Yes, we use, typically has been used in the past, what they call AFFF, which is aqueous foam that basically that allows to break down the surface tension of the water that's applied to it. So aqueous film forming foam is the AFFF. It does a pretty good job, as well as it reduces the amount of water that needs to be placed on the fire itself. So those are some of the organic retardants that we have. It also prevents rekindling of fires from that. This issue came up about 5 years ago when the city fire chief called me and says, "Can you come to the fire scene?" And I said, "What fire scene?" He says, "Where do you live?" And I said, "South." And he says, "Look north." And that's when the mulch fire was burning downtown. And I went to the scene. He says, "How do you put this out?" And I said, "You use foam." And so they brought in overnight. They brought foam, and it's typically it typically operates like shampoo, which basically breaks down the surface tension of the water and allows it your hair to absorb the water. So so that's why fire trucks now are equipped now with the foams to allow them to do that, especially with in conditions in which maybe freezing or having other problems. It also it takes care of a lot of the environmental issues of runoff. So lots in that area. And these are issues that come about with on a lot of the nuclear power plants of what to contain and what to be used in there. And NRC has bundles of information about this. One of the most areas that they're most concerned about are cable trays, and also like I said, the study that one of our doctoral students has completed is whether or not that you have to replace radiated cables that have been in service for a great number of years. So that has always become an issue of whether or not you can get another 10 or 20 years out of it. So, so the cable trays, like I said, represent a significant hazard to fire development and growth. So, like I said, this one student figured out, and we were actually in cooperation with Oak Ridge National Lab, actually radiated cable for us, some accelerated cable. So these are, like I said, these are newfound issues that we never thought we had in the past, but the solutions were pretty quick.
Yeah, one other thing that's always kind of fascinated me is we have a lot of old buildings on campus, and I can only speak to the campus. And those old buildings, over the years, there have been new requirements for ADA and requirements for fire. But the old buildings, you know, some of those get grandfathered in. I think the interesting thing is at some point, you know, the university might like to go in and renovate and make 2 small classes into a big class and do these things. And when those things happen, the fire marshal gets involved, and you're not allowed to do any renovations unless you bring the whole building back up to fire code.
Mm-hmm.
And sometimes that requires modeling to find out how do you take an open staircase and put plexiglass up or put fans in to make it so that it's going to meet the new code, I guess, requirements. And I just remember, you know, I remember when we were talking about doing that with the EECS building, you know, years back, that you weighed in on that open staircase because there was going to be renovations upstairs. And I think we ended up not doing any renovations, but I think that's interesting when you walk into a building, you're like, well, this building doesn't have fire enclosed, fire or smoke enclosed staircases, which are kind of a requirement now, unless you have special, you know, fans and things set up. But I guess the reason is because those are grandfathered in.
Those solutions, I remember when you all came over for that, and the facilities person said, "How did you come back quickly with all these answers?" And I said, "Well, I had about 10 years to think about it." And but renovations are easy. They have you can actually retrofit a building if you use what they call sidewall sprinkler heads, and you can hide it in just about anything that you need. This is a common thing in hotels that are retrofitted, and so it's not that hard to bring a building up to code with that, and not have to destroy the fabric of the building itself. You know, those sprinklers as well as exhaust and some other areas could easily put that building back into tip-top shape.
I also remember Estabrook when it wasn't sprinkled, and then they said you have to get it sprinkled, and until you get it sprinkled, you have to have a fire watch. So someone had to walk through that building like every so many hours, 24 hours a day, until they got it sprinkled. So that was another interesting one about old buildings that no longer meet code.
Yeah, I sort of weighed into that. They spent more time putting an alarm system in than they could have put just a regular sprinkler system, a retrofitted sprinkler system in there. So, but the problem with that building was we got to look at the interior of the spaces within the walls, and a lot of the wood structure had basically decayed. So even though the sheetrock walls were covering up basically some decay that could never have been done. When the state fire marshal was there, we got up in the attic. They let me up there, and they had already had a disastrous fire in the 50s. And they had cobbled the beams back together again, some things that I would never have done structurally. But it was a situation where unfortunately, that building outlived its existence. And the other thing that happened with that was that we had a fire modeling class in there, of all things, and we went ahead and modeled the building. and showed what smoke distribution would have been if just they had a minor fire down the stairs. That was enough to scare everybody. The other thing that happened was one big area is the storage and of dumpsters. So one day somebody looks out the building and it's a pre-football game day, and they've got like 3 dumpsters lined up underneath the structure, the metal structure of the stadium. And we got to looking at it, and that overhead was the main fiber that comes into the university. Was run above that, and then they went to the emergency generator. So the class calculated what was the maximum heat exposure that cable could have had, and so we basically sent a note up to the safety folks and said, "Listen, one dumpster is okay, but if you have more than one dumpster there, you're going to be in grave problems." So. The other problem with Estabrook had to deal. The reason they had the fire watch is that if during a football game, if that building caught fire, the superstructure that holds up the sky boxes have no fire protection coatings to them, and there's no active fire protection. So somebody asked me what's going to happen, and I said probably the sky boxes would fall off the side of the building. And that's what started the fire watch issue. So it was. I'm sort of glad that it's down. I'm glad that there's a new building that's coming up there, and sometimes you just have to leave a mark for that.
Yeah. Well, Dr. Icove, thank you so much for sharing your time with us today. Much appreciated. We're just about out of time. I also want to make an announcement to the students who are in NE 501. We're going to have a special seminar this Friday at noon to 1. A researcher from General Atomics who's an expert in fusion. Her name's Livia Casali. She's going to come in, or she's going to be given a seminar, and you can use that seminar to meet one of your seminar requirements. So I sent an email out to the class. I hope those things work, but sometimes they don't. So hopefully everybody got the email, and there's a seminar announcement out there. So love to have you guys join us on Friday for that special seminar. And Dr. Icove, thank you very much again. I like the orange, flying the flag. Have a great evening. Bye-bye.
Thank you, and I'll send to you the PDFs of the PowerPoints as well as the syllabi for these courses if you want to redistribute them.
Okay, will do. Thank you very much.
Thank you.